Hello and welcome back to ParticleWorks Power-Ups. Today's request comes from a Formula One engineer looking to streamline their piston cooling simulation setup, a crucial task when optimizing both performance and efficiency. They're analyzing how changes in the size, number, position and orientation of cooling jets affect heat transfer. But there's a catch. For each design iteration, they receive from the design team the orifices of the jets as individual OBJ files. While we could use these for a file inflow, to ensure particles are generated evenly across the entire surface, they want to replace them with a circular inflow of the same size, orientation, and position. At a first glance, this might sound like a complex task, but with the ParticleWorks API, we can automate the entire process with surprising simplicity. And as a bonus, we'll take this opportunity to demonstrate how user input can be integrated into our macros, making them even more flexible. This macro is slightly longer than usual and includes some complex linear algebra. Rather than explaining each line of code, I will walk through the key steps and the purpose for each section. As always, we begin with our initialization, but this time we need a few additional libraries to handle mathematical operations and data processing. Some of these are non-standard libraries, meaning they will need to be manually installed in the version of Python bundled with ParticleWorks. If you're unsure how to do this, please refer to the first episode of this series. The macro defines four key functions that handle the mathematical transformation required for converting a set of nodes into inflows. The normal vector. This computes the normal vector from a plane given 3 points. This is crucial for determining the orientation of the input geometry. Calculate rotational axis. Determines the axis of rotation needed to align one vector to another. Calculates rotation angle. Computes the angle of rotation required to align the vectors. Construct rotational matrix constructs a rotational matrix that can rotate a vector around a given axis by a specified angle. These functions encapsulate the complex calculations, allowing the rest of the script to remain readable and focused on the overall task. Next, we create a dialog window to allow users to specify which nodes should be converted into inflows. This includes selecting a parent node. The users pick a parent group and the macro processes the child nodes within that group. The add node ref function is used to generate a drop-down list of available nodes within the scene. And secondly, an option to delete the original nodes. A simple Boolean option is provided to let the users remove the original nodes after the conversion. Once these inputs are defined, the ask function displays the dialog and stores the user selection. With the user input captured, the script retrieves all objects under the selected parent node. We can retrieve the answers of the user input using the get function. For each of these nodes, the following steps occur. 1. Reading the OBJ file data. The script opens the corresponding OBJ file and extracts all vertex coordinates in X, Y, and Z space. These are stored in a pandas data frame for easier handling. 2. Computing the center point. The geometric center of the object is calculated as the mean of all vertex of the coordinates. 3. Calculating the normal vector. The script selects 3 points from the surface and computes the normal vector using the normal vector function. Since the normal could be flipped in the wrong direction, the script checks whether it points in the positive y direction, which is assumed to be upward for the piston geometries. If needed, the normal is then inverted. I have hard-coded this to the y direction here, but this could be another question within the user input. Determining the required rotation. Essentially, we use the 3 other functions defined above to calculate the rotation. In mathematics, this is called the Rodriguez rotation formula, and you can learn more about it online if you're interested in understanding the process. This returns a list of the x, y, and z rotations required. And finally, determining the inflow size. The script finds the maximum distance from the center point to any vertex in the OBJ file. This distance represents the inflow radius, which is doubled to compute the diameter. Now that we have all the necessary data, finally we're ready to create the inflow. The script creates a new inflow node in the ParticleWorks scene. The diameter is set based on the computed size. The location is set to the computed center point. The rotation is applied using the computed Euler angles. The name is preserved from the original node. If the user opted to delete the original nodes, the script then removes them from the scene. Finally, the script moves on to the next node in the list and repeats the entire process. This macro automates a complex task, significantly reducing manual effort. If the user had to compute these transformations manually for each inflow, the process would be extremely time-consuming and error-prone. Instead, by writing the macro once, users can convert multiple nodes in seconds with a high degree of confidence in the accuracy of the calculations. Enough explanation, let's see the macro in action. Here we have a simple piston model. I have already imported my jet surfaces as individual OBJ files and collected them all in this group. These are the surfaces that will dictate the size, position, and orientation of the inflows to simulate our piston cooling jets. You will notice that I will want all of my jets pointing in the positive Y direction, so no need to change anything in my script. Let's now run the macro by dragging and dropping the Python file onto the viewer. This will then open a dialog window, which first I need to select which group is the parent of the surfaces I want to convert. For the optional cleanup, I'm going to disable this so we can see how well the new inflows match up to our existing surfaces. Clicking OK will then execute the macro. And that quickly, the macro has performed all calculations for all surfaces and created our 4 new inflows, perfectly matching the position, size, and orientation. If you have a problem you'd like our help with, our contact details are on screen now and in the description below. For more information about our full API online training course, visit our contact page for details. See you next time.